Hello everyone, welcome to my channel. In this video, we will talk about the spring mass and damper system, and we will see how it helps in understanding the different type of mechanical analysis. So there are three components in spring mass and damper system. The first component is spring, second component is damper, and the third component is mass, which is suspended over the spring and damper. The external force F may be there or may not be there. If it is zero, then it is called static analysis. If there are some non-zero force in the system, then it is called dynamic analysis. For the thorough understanding of the static and dynamic analysis, I have created a separate video. You can check that video by clicking on the I button. So we will see all the three components one by one. The first component is spring. This spring is having a stiffness K. Because of this stiffness, there will be some internal resistance in the overall system. The second component is damper, which is having the damping coefficient C. Damping is basically a energy loss. Because of this damper, there is an internal resistance force. The next component is mass, which is suspended over the spring and damper. Because of that mass, there will be an inertial force, which is the internal resistance force due to vibrate mass m and acceleration x double dot. Here we have kept all the three components in a single diagram. For the thorough understanding of the static and dynamic analysis, we need to understand the governing equation of motion. For that, we have a spring mass and damper system. The mass m is suspended by a spring of stiffness k and a damper of damping coefficient c. The external force F is applied on the mass, which will displace the mass m in downward direction. The internal resistance force to vibrate mass m with acceleration x double dot is known as the inertial force. Inertial force is the product of the mass matrix and the acceleration matrix. The internal resistance force due to the stiffness of the spring is equals to the product of the stiffness matrix and the displacement matrix. Damping is the energy loss. In absence of damping, the system will keep vibrating forever. The internal resistance force due to damping is nothing but the damping force, which is the product of damping coefficient and the velocity. So according to the governing equation of motion, the total external force F is the sum of the inertial force, damping force and spring force. This governing equation of motion will change according to the type of the analysis. We will see how it will change in the static and dynamic analysis. When we talk about the static analysis, the constant force because of the constant mass produces some constant displacement x. After that, the system becomes static. Because of that, there will no acceleration and velocity in the system. Therefore, when we talk about the governing equation of static analysis, the inertial component and the damping component of force is going to be 0, and we will get the final governing equation for static analysis is the product of stiffness matrix and displacement matrix is equals to the external force. When we talk about the dynamic analysis, you can see in the animations, since the displacement is changing with time because of the time varying load, there will be some velocity and acceleration in the overall system. So we will get the governing equation for the dynamic analysis is the sum of the inertial, damping and stiffness force is equals to the time varying load. If you like this video, kindly subscribe my channel for more such important videos. Thanks for watching.